Okay, we're moving on to number 4 now. Bob invests 600 euros in a bank that offers a rate of 2.75% compounded annually. Obviously the word compound is a huge clue as to our method, and so we've got a choice of methods. We can use the formula where we know that says how much money does Bob have in the bank after 4 years. So we could use the formula where future value is equal to the present value times 1 plus the interest rate divided by 100k, where in this case k is 1 because we're only compounding once each year, and then it's to the power of kn, where again k is just 1 and then n is the number of years, or 4. And so we could just type this into the calculator: 600 times 1 plus 2.75 over 100, close parentheses, raised to the power of 4. And we can see that the money, 600, after 4 years has grown to 668.77. And that's euros. Another method we could have used is in apps, finance, and TVM solver. And so the number of time periods that have occurred, well, if we're only compounding once each year, and it's 4 years, that is 4 compounding periods. The interest rate is 2.75%. The present value, Bob has to give the money to the bank, and so he is losing 600 on that particular transaction. He's not making any payments, and we're looking for the future value of the money. You'll notice that P over Y and C over Y are demonstrating that we're only compounding once a year. And so the future value is alpha, enter to solve, and we get, there we go, the same number, 668.77. You'll notice that I've rounded to 2 decimal places because it's a money problem. Part B, calculate the number of years it will take for the investment to double. Well, double means that we're dealing with a value of 1200. So 1200 now, his original 600 is growing at a rate of 2.75%. For how many years? Let's raise it to the power of x. So that's the equation that we're trying to solve. Let's not fool around with algebra. Let's use the calculator to do this. Now, because it's only compounding once each year, maybe the table would be the best method, but let's first put in the y1 and the y2. I always like to, no matter whether I'm using the graph or the table, let's put in the left-hand side and the right-hand side, and now I've got a choice of methods. So 600 times 1 plus 2.75 over 100 raised to the power of x. Alright, and I'm going to use the table approach because I know that I'm not receiving the money until the end of each year. And so we need to wait until a complete year has passed before we receive each new amount of interest. So if I look at the table, I'll see that Bob's only going to surpass 1200 when he receives the payment at the end of the, almost there, there we go, at the end of the 26th year. Now if I solve this with a graph, maybe I'm going to get 25 point, I don't know what, but, and well, IB might accept 25 point something or other, but I think a much better answer is 26, because we need to wait until the end of that 26th year, until 26 complete years have occurred, in order to receive that final amount of money at the end of the year to finally put us over. Now to show our work for a table then, I'm just going to say what my 2 functions were. y1 is 1200, y2 is that formula we've been using, and then I'm going to include my 25th row where I didn't quite have enough, and my 26th row where I finally get over the amount. And I'm rounding to the nearest 10 cents there. Okay, and let's actually answer the question then. Therefore, 26 years. Anne invests 600 euros in another bank that offers interest compounded annually. Her investment doubles in 20 years. So her investment has doubled to 1,200, and she invested 600. We don't know what the interest rate is, and it's 100 times 1 because it's again compounding annually to the power of 1 times, and it took 20 years to do this. So now we're solving a different equation. So let's just go back into our y equals, and we'll change the right hand side of the equation slightly by coming over to the 2.75 and changing that to simply an x. And we're trying to figure out what is that percentage, that x value. And the power now is not x, the power is 30. Oops, 20, sorry, 20. Okay, now this time I do need to solve it with a graph because r doesn't have to be a whole number. It's possible to have 5.73% rate interest, isn't it? Because it's possible to have a decimal answer here, I should do it with a graph. And before I graph it, let's set up my window. I can see that one of my functions is a horizontal line at 1200. Oops, I shouldn't have done that. Let's do this. And so that means that I need to set up my y max to be at least 1200. Anytime you've got a constant on one side, I'm going to make it 1300 so it easily fits. And then what are reasonable interest rates expressed as percentages? Well, she's not growing her money with a negative interest rate, so let's start that at 0. And I doubt that she has a rate as good as 10%. So let's graph it with 10 being the maximum. See what we get. There's the 1200 constant function, the y1, and here's our growing function. Alright, we can see that the interest rate is going to be about there. It looks like 3-point-something%. Let's find the exact amount. Second calc, intersect. And our first curve is the horizontal, the y1. The second curve is that growing one, the y2. And our guess, that's fine, my cursor's fairly close already, and I end up with a value of 3.53%. And so our interest rate is 3.53%. And in order to show my work, I should just draw a quick sketch of the graph. And so I've got my 1200 there. That's y1 is 1200. Let's just label it. And then I've got another function here, and that's my y2 is 600, 1 plus r over 100 to the power of 20. And then the intersection point, I should label that as 3.53, 1200, and of course it's the 3.53 that I'm interested in, and there's my answer. Number 5. You'll notice that we have to give all answers to the nearest whole currency unit, so we won't be dealing with any decimals here. In January 2008, Larry had $90,000 to invest for his retirement in January 2011. You'll notice that that is exactly 3 years later. Now, I shouldn't have given you the first part of this question because simple interest has been removed from the curriculum, which is why we didn't study it. So I'm just going to give you the answer for part A so that we can continue to do the rest of it. Just for your interest, funny, whoops, simple interest occurs when you've got 4% of the 40,000 in this case. And if we do 40,000 times 0.04, we notice that we get 1,600. And simple interest means that we get that amount each year. And if 3 years have passed, well then that's going to be 4,800, right? So that's the answer to, so it says calculate the value of Larry's investment. So he has the original 40,000 plus this 4,800. That gives him a total then of 44,800 US dollars. And there's your answer to part A. So sorry, that should have been given to you. 44,800. Here we go. Larry changed the investment into South African Rand and we can see the exchange rate, so we're expecting to get a much higher number of rand, considering that we get 18 of them for each $1. Calculate the amount that Larry received from the exchange. So 44,800, I think it's pretty clear that we need to multiply by 18.624 in order to get a larger amount. So 44,800 is multiplied by 18.624, and wow, that can't be right. Oh, I see, I've got an extra zero here. Let's start again. 44,800 times 18. Still going to be a huge number, isn't it? Alright, now we're supposed to give it to the nearest whole currency unit, so that gives us 834,355 South African rand. Wow. He changed the remaining 50,000 to South African rand in January 2008. The exchange rate at that time was $1 was worth only 10 South African rand. And there was also a 2.5% commission charged on the exchange. Alright, calculate the value of the commission that he paid. So he was dealing with 50,000 at the time. So the 50,000 is multiplying 2.5%, or 0.025. And let's see what we get. 50,000 multiplied by 0.025. The commission he paid was $1,250. Wow. Expensive. Now, show that the amount that Larry had to invest is 517,000. Okay, you know what? I'm just going to ignore the answer, because I might need it for a later question, but I know that when I see show that, I must ignore this answer. Do not write it down anywhere unless it's the very last thing you write in the question. Okay, it's got to be the result. So, let's work this out. The 50,000 that he originally had has had 1,250 of commission removed from it. And so now he's only got 48,750 to convert. That 48,750 is converting to South African rand at a new exchange rate, or in fact it's the 2008, it's the old exchange rate, because this had happened before he retired in 2008. Multiplied by 10.608. Oops. And of course we need to round. Oh, well, that's nice. It's already a whole number. 517. Now I must write down this complete answer that the calculator gives us, and then I must show that this rounds to 517,000 as required, correct to the nearest thousand. You see, it's been rounded to the nearest 1,000. In January 2008, Larry deposited this money into a bank account that paid interest at a nominal annual rate of 12% compounded monthly. Find the value of the money in his bank account in January 2011. Okay, so his South African rand of 517,000 is growing at a rate of 12%, but it's compounded monthly, so my K value is 12, and it's going to be in there for 3 years, right? Because this all happened in January 2008. Obviously, I could also use the finance application to do this, and so I'll show you that in a moment. Let's just type this in. 517,000 times 1 plus 12 over. Now this is a place where you need to be careful. We need to put the 100 times 12 into parentheses so that all of it is treated as the denominator. Now let's close the parentheses that I actually wrote down in my expression and raise it to the power of 12 times 3. And looks to me like he ends up with 739,707 South African Rand. I think that IB would also accept an answer where you would use the more exact value instead of the approximate value. I think that either would be okay. Looking back, I actually kind of wish I had used the more exact value, but no, I think both are going to be okay. Now, I said I would show you the finance method, so let's say apps, finance, TVM solver. So let's see, if we're compounding monthly, that's 12 times each year, and it's happening over 3 years. That's a total of 36 compounding periods have occurred. The interest rate is 12% per year. The original value of the deposit was negative 517,000, if I'm using the approximate amount so I can compare it to what I've already found. Payment's always zero now in the new version of this course. The future value is what we're trying to find, but before I do that, I need to show that the number of periods, or compounding periods per year, is 12. Let's now calculate what the future value is by clicking on it and saying alpha enter. And there we go, 739,707, and then I have been asked to round to the nearest whole number in this question. I should have reminded you that to write down your work on finance, we should just write down that entire screen. N is 36, I% is 12, PV is negative 517,000, PMT, I don't think you need to write down this line, I certainly won't mind if you don't. Future value is 739,707, and I'm going to include that just to show the entire thing. Of course, I've already got my final answer rounded to the nearest 1 right there. And the P over Y and the C over Y are also important, especially in this case because they're not equal to 1. You need to show that it's compounding monthly. Alright, number 6. Members of a certain club are required to register for one of 3 games, billiards, snooker, or darts. And we can see the table of data has been given. We need to use a chi-squared test at the 5% significance level to test whether choice of games is independent of gender. So here's our gender classification, male or female, and billiards, snooker, or darts, that's the choice of game. State clearly the null and alternative hypotheses tested. Okay, so our null hypothesis is that gender and game choice are independent factors. And the alternative hypothesis, H1, is of course the opposite, that gender and game choice are dependent factors. Now then, we need to give the expected values. So to do the expected values, let's go into matrix. Matrix. And I'm going to create a new 2x3 matrix. Let's edit it and put in the values 2 by 3, and then I've got 39, 16, and 8, and I've got 21, 14, and 17. So that's good. And now I'm going to say stat tests, and I'll do the chi-squared test. And the observed values are matrix A. The expected ones will be spit out in matrix B once I've done this chi-squared test. Calculate. Alright. So let's have a look at matrix B for a moment so that I can write that down, because those are my expected values. So I'm going to look at the matrix named B. Well, those are really nasty numbers, so I'm going to round them off. my expected values. Oh gosh, I don't have the room here, sadly. Maybe I can squeeze it up at the top? Perhaps. So I'm going to write my expected ones here. So that's male and female and billiards, snooker, darts. Alright, and now I'm just going to approximate these values. So 32.9. And, well, actually, I suppose it's not really very realistic, is it? How can you have 32.9 people? I'm going to leave it like that for a moment, because expected values are kind of theoretical values. I'm not really certain whether they actually need to be whole numbers. I suppose you can't, well, you have to think about this. How could you expect 32.9 people? Anyway, I'll come back to it. 27.1. And then I've got 16.4 and 13.6. And then for the darts, we expected to see 13.7 and 11.3. Now, just by comparing what we observed to what we actually would have expected, I can see there is some fairly significant departure. The ratio of snooker players seems to be really almost spot on from what you would expect in a perfectly random situation. But look at the billiards players. What we observed was way more billiards players than what we should have expected to see in a random situation. And we've, for men anyway, and we've got way less darts players. It seems like the women tend to play darts more and less billiards, while the men do the opposite, than what you would have expected. So I wonder, it's possible that the chi-squared value, which is the measure of the total departure between the observed and expected values, might be so large that we could say, whoa, it's too big. There's too big a difference. They're not random. It's not independent. So I need to calculate the value of chi-squared. I did do that, didn't I? But I've already lost it, so I better do it again. Stat tests chi-squared, and I'm going to write down the, oh shoot, try again, stat tests. There we go, oh golly, sorry, it must be so agonizing to watch me make mistakes like this. I'm telling you, it's not me, it's the calculator, right? Come on. There we are. Chi-squared test, calculate. Good. Now the degree of freedom, that's one of the things I'm supposed to write down, the degrees of freedom. So df, I'm just going to show the calculation here, because why not? I've got 2 rows minus 1 times 3 columns minus 1. That's 2 times 1. Degree of freedom is 2. I can see that my chi-squared is 7.79 when I round to 3 significant figures. And I can also see that my p-value is 0.0203. Now there's 2 different kinds of chi-squared tests I can do. I can compare my chi-squared value to my critical value, which we often use the value k, and the critical value would have to be given to you in a question. In the old days, I mean, even last year, you would have to look it up in a table that was at the back of the formula booklet. Nowadays, in the new curriculum, starting with you guys, they're going to give you the critical value. And so if the chi-squared value is less than the given critical value, then we will accept the null hypothesis. So these are the ones where we accept H0. If chi-squared is smaller than the critical value, or if the p-value is greater than the significance level, which is the one expressed as the percentage. Now, we have not been given the critical value in this question, so we can't compare chi-squared to the critical value. Instead, we're going to have to compare our p-value to the significance level. is P greater than the significance level? Well, if I compare my p-value, 0.0203, if I compare this to the significance level of 5%, which is 0.05, in fact it is less than. And because p is not greater than the significance level, that means I do not accept h0. So in this case, I'm going to reject h0. Don't know where I'm going to write this. I will reject the null hypothesis. Therefore, gender and choice of game are not independent factors. Okay, and we have to see why. I mean, we have to understand that what you're comparing is, you're realizing that p is less than 5% in this situation. That's your type of chi-squared test, because we couldn't do this one without the critical value. We had to use the other type of chi-squared comparison. And then part B, let's suppose that the chi-squared test were applied to this new set of data. Why would it be necessary to combine billiards with another game? Well, gosh, this is something that we haven't actually spoken about, but it's because I think that our value here is too small. We're supposed to have at least 5 in every single cell in order for the chi-squared test to be valid. Now I'm kind of curious as to find out whether this also happens on the expected values table, because I thought it was in fact the expected values table where they all needed to be at least 5. So humor me for a second. I'm just going to find out what happens if I change matrix A to a 2 by 4, and then I put in this data: 4, 15, 8, 10, and then 10, 21, 17, and 37. And then I'm going to quit, and I'm going to do stat chi-squared test. And yes, calculate. And let's now look at the matrix B. Matrix B, enter, enter. Okay, alright, then I feel a little bit better. I'm pretty sure you need to look at the expected values. And if it's the expected value, if you have any expected values less than 5, that's a problem. It means that the chi-squared test is no longer going to be reliable. So that's why it's necessary to combine billiards with another game. You can say something like, we need at least 5 people in every cell? I don't know. I guess so. Alright, which other game would you combine with billiards and why? Oh boy. Well, that's a tough question. I guess we would combine billiards with snooker? Because they're similar? Gosh. Or would we combine billiards with darts because they both got the lowest value? Boy. I'm a little stumped. I should look up the mark scheme. I don't think I have it handy, so maybe I'll get back to you on this right before the test. Let me just reassure you and say there is not a question like this on the test. This is a very old question where they gave questions that were a little tougher and even stumped teachers. Sorry. Number 7. 10 students were asked for their average grade at the end of their last year of high school and their average grade at the end of their last year at university, and the results were put into a table as follows. So you can see that in high school they were graded according to percentages, while at university it looks like it's done kind of more by GPA. We need to find the correlation coefficient R. So let's just check that my correlation coefficient is on. I'll press mode and up, and see if my stat diagnostics is turned on. It indeed is on already. And so now I'm ready to enter in my x values into list 1 and my y values into list 2. These are not x values nor y values. These are just the numbers of the students. It's the x and the y values, the actual data that I'm looking for. So let's put those into list 1 and list 2. Now if I press stat and edit, I'll see that I've got these old lists in here. I can get rid of these lists by going up until the list itself is highlighted and then pressing the clear button. Don't press the delete, press the clear button. If you press delete, you'll actually delete the entire column and you won't have a list 2 anymore. Again, up to here, clear, done, right. Let's put in the values. Skip ahead if you must. Alright, thanks for your patience while I entered in that data. I'll exit now so I can go stat, calc, and I'm going to say linreg, knowing that my diagnostic is going to turn on and show my R value. Finally, 0.761. Oh, whoops, it says to 2 decimal places, so R value is 0.76. Describe the correlation between the high school grades and the university grades. So we've already seen that an R value like 0.7, around that neighborhood, is a pretty weak correlation. I'm going to call it weak moderate because I guess it could be worse, couldn't it? But it's a positive. So I'm going to say positive, moderately weak correlation. Find the equation of the regression line. Well, that's given to us in the linreg. Y equals ax plus b. So a is equal to 0.051838. No harm in including additional decimal places. And my b is a negative. So perhaps I'll just write it minus straight away. Minus 1.288 47. Let me just round it up to 5 at this point. I'm not going to get any fussier than that. So I ended up including 5 significant figures. No big deal. Okay?